Okay, so hybrid functions are, I guess, a snapshot of a multiple number of functions just defined over different domains. It could be two, there could be three, it could be any number of functions defined. So as you sort of see here, what's it say? It's functions which have different rules for different domains. Okay, so I guess the process is really just sketch the function over the appropriate domain, and then you end up with one rule to represent everything. So if we consider these functions here, so let's go blue, green, and yellow. Okay, so if we start with our blue function there, minus x minus 1. So y equals minus x minus 1, or f of x equals minus x minus 1. So it's a y-intercept at negative 1. It's a negative gradient, so 0, take the x across, we get a x-intercept at negative 1. And so if I was to sketch this particular graph, it would look something like that. So that's the graph over the full domain. Okay, but once again, our graph has been restricted for, I'll use blue. It's been restricted for just these negative values of x. So we rub out the section that we don't want. And then the first decision is, okay, that point there, have a look, strictly less than, so I need a hollow dot there, and we'll put that coordinate down as a point 0, negative 1. So that's that section of the graph. Let's think about 2x, the graph of 2x minus 1. Again, the y-intercept at negative 1. So it's going to go through there. And if I put y equal to 0, 0 equals 2x minus 1, so x will equal a half. So maybe it goes through about there. So again, a straight line, something like that. That's the full graph. But again, just between 0 and 1. So the green section has a domain just between there and there. So let's again rub out the sections that we don't want. Now on the graph, so let's have a look. 0x is greater than or equal to 0, so solid dot, and hollow dot here at 1. What we do need to check is to see what the coordinate of that point is. So if I put x equal to 1, y is equal to 2x minus 1, which is equal to 1. So it should be the point 1, 1. So I haven't drawn it anywhere near steep enough, have I? So I might redraw that. It should go through the point 1, 1, which is up there. And we said it was a hollow dot. And so it goes a bit better like that. Actually, that goes more through a half, doesn't it? So there's that green section. Let's have a look at the yellow section now. And the yellow section says it's where y is equal to 2, which is probably up here. Yeah. And we'll call that point there at the point 2, where x is greater than or equal to 1. So a couple of things we need to tidy up. So at x equal to 1 is here. Let's go through there. So we don't go there at all. The yellow graph is greater than or equal to, so it's a solid point there. And so I've just noticed our green graph here, it's a hollow point there. So we have something like that. So there's my yellow domain, my green domain, my blue domain. Okay, so I guess I won't put an arrow just on that. just so we know that those x values correspond to those y values. So that's my hybrid function. That's the graph of the function. So we can see there's a break in between here. Okay, so we'll talk about continuous graphs and things like that. So it's not continuous. So the important thing is, let's evaluate the function. So f of -1 means put x equal to -1 and work out the rule for the function. So the first thing we need to do is we go to our hybrid function and we make a decision. I'm going to just recolour those in again. We make a decision on which of these graphs are defined for the value that we're interested in. So the value I'm interested in here means x is equal to -1. So x equal to -1 fits into the blue function, so I substitute -1 into that. F of -1 is equal to -1 minus 1, which is a +1 minus 1, which is equal to 0, which is that point there. F of 0. Let's look at our graph. Whereabouts does 0 fit? 0 fits into the green function here. So f of 0 is equal to 2 times 0 minus 1, which is equal to -1, which is that point down there. What about f of a half? Where's a half? A half fits into the green function as well because it's between 0 and 1. So f of a half is equal to 2 times a half minus 1, which is 2 times a half, 1 minus 1, which is equal to 0, which is that point there at the intercept. See, that's the only value it can be. At x equal to a half, if we travel along our x-axis until I find x equal to a half, it's that point there, and so it's that value. All right, so that's the only function we can put it into. F of 2. What's f of 2? Well, f of 2 is this one here where x is greater than or equal to 1. So 2 is greater than or equal to 1, so it's just the yellow function. F of 2 is equal to, well, it's equal to 2 everywhere. So f of 2 in particular, that's 1, that's 2. So that's where x equals to 2. And so we're talking about that point there. Okay? So you don't substitute the value into all the rules and get 3 different answers or 4 different answers depending upon how many functions we have. It only ever fits in one place. Okay? And so we substitute it into that. Let's have a look now at the range of this particular function. Let's grab a colour I haven't used, say black. What's the lowest value on the function? It's down here. So the range, the lowest value is in fact at -1, and it goes all the way up, doesn't it? Now, even though there's no y value, there are y values over here on the blue graph. So I can get a y value anywhere between -1 and infinity. So there's my range. All right, now you can put any sort of graph in the function to sketch, and we'll have a look at that now. So exactly the same process. Let's have a think. I'm going to use colour coding because I like colours. Blue, green, and yellow. Blue graph, y equals x plus 2. Sketch the graph of x plus 2. I'll call that the point 2. We'll call that 2. So if y equals x plus 2, y-intercept is 2, put y equal to 0, x equals -2. Positive gradient, so that seems to make sense. So that's what it looks like. Now, I sketched this graph for x less than -2. So I did decide that that was the point -2. So I'm going to get my eraser. And all these points are not relevant. Now, is it strictly less than? It is strictly less than, so I'm going to put a hollow dot there. And if you like, that's the blue domain that we're talking about. What about x squared minus 4 between -2 and 2? Well, x squared minus 4 is a parabola shifted down 4 units. So 4 units, if that's 2, that must be -4. So if y equals x squared minus 4, to find my x-intercepts, put y equal to 0. X squared is equal to 2, so x equals plus or minus 2 of the intercepts. So I'm going to come down in a nice parabolic curve and back up again. Now, what about solid and hollow? Solid point at -2 and a hollow point at +2. So let's just get rid of that. And again, there's my green domain here between -2. Maybe I should put those points -2 and +2. And then we have a hyperbola for x is greater than or equal to 2. So what does hyperbola look like? This one here has a vertical asymptote at x equal to 2. So I have a vertical asymptote at x equal to 2. It hasn't been shifted up or down at all. I know I've got a horizontal asymptote. I only have to draw the horizontal asymptote for this section because that's all it's defined for. So if that's 2, that's 4. So give me an idea of a starting point. I might just put x equal to 4 into that graph. 1 over 4 minus 2 is 1 over 2, so it's a point 4.5. So if that's 2, that's 1, 2, 3, oh, it's 2 of them. That's a half, so a half might be, I don't know, about there somewhere. So I'm just going to sketch my hyperbola in that section there. And that looks pretty right, I think. So it's a hyperbola. It's shifted across 2 units to the right. There's no x-intercepts or y-intercepts. So there's my graph. There's the 3 sections of my graph. So obviously the big difference in this one here is at x equal 2, my graph isn't defined. That's really interesting, isn't it? That, look at that, greater than or equal to 2. So x can't be 2 in that. What if they're just saying that means you have to include your asymptote? What I might do is I might get that a bit nicer. So let's just go a bit more like that. Looks a bit better. All right, sketch the graph of f of x. We've done that. Evaluate the following. F of -3. So -3 is in the first section, the blue section. So f of -3 is equal to -3 plus 2, which equals -1. Substitute it into the right section. 0. For which section is 0 fit? 0 fits into the green section. So f of 0 is equal to 0 squared minus 4, which equals -4. And f of 2 fits in the yellow section. And if I put 2 into that graph, it's actually the asymptote, isn't it? So it's the asymptote, which means it's undefined. Okay? So it's a little bit unique, that spot. The range of the function, well, what y values can I have? Let's have a look at the blue section. This blue section means it continues to go all the way down. So from the blue section I get from, or even if we sketch it, I get from -infinity up to 0. The green section gives me from, what's the green section give me? It gives me from inclusive -4 to 0 inclusive. And the yellow section gives me from +infinity to 0, but it doesn't reach 0. So between all 3 graphs, might as well do black, I get as low as -infinity and I get all the values in between, positive up to positive infinity. All right. So there's every y value that we get. Okay, off we go.